Hello students, now we are going to understand about the concept projection of solids. So as per the syllabus, we are going to keep the solids only on HP. So in this case, either you are going to keep the solid on, either you are going to rest it on the base edges or base corner. Now in this case, what we have kept for a square prism is resting it on base. When I'm going to tilt it, it is going to be resting it on one of the edges. So I need to keep the edge on the right side. In case of planes, we have kept the edges or the corners, keeping it in the left side. But in this solids, we are going to consider keeping it edge or corner on the right side when we are going to tilt towards the right side. So now we are going to see this is a square prism. All these lateral faces are perpendicular to the top face and the bottom face. Right now I'll remove this VP and HP for understanding of this problem. Now this is a square prism. It has got 4 lateral edges, 4 top edges, 4 bottom edges. So whatever the problem we are going to be solving is based on the regular solids. So regular solid means all these lateral faces, 4 lateral faces, is going to be perpendicular to the base and also the top face. Now the important thing is how we are going to be solving the problem for the given question. Now the square prism, 35 sides of base and 60 axis length rest on HP. On this problem, whatever we are going to solve is going to be resting it only on HP, on one of its edges of the base. So first thing is I'm going to draw thin line. So I'll show the grids. So keep this line till here. Make sure that it's going to be thin line. So in the first box, write X capital letters, Y in between. In the second box, write VP, HP. Now in top view, we are going to start drawing the top view first. So this is the top view of a square prism. So top view, we are going to be able to see a square. I am going to draw a square here. So from this, any distance, it can be from any distance. So start it from the third box. The other box is for giving the dimensions. So I'll keep here, this length is equals to 35, and from here 35, then here 35 and 35. Top view is going to be drawn in thick lines. As soon as you draw any polygon, give its dimensions. So from distance from this edge to this dimension line should be 10 mm. Now I'm going to draw the diagonals. So diagonals is a construction line. It is going to be a thin line. So here I'm going to draw a construction line now to find the center point of the square prism. So I'm going to give the namings. So this is A, this point is B, this is C, this is D. The corresponding edge, so if I'm going to call this point is A, this one I'm going to call it as A1. If I'm going to call this point is B, this is B1. This is C. The edge on this point here is C1. Similarly D. So here I will show as a wireframe. If this is the D point, this is D1. So here I'll be keeping it, I'll be able to see the point A, I'll be able to see the point B, I'll be able to see the point C, I'll be able to see the point D. But the corresponding edge which is at the bottom face is A1 is not visible in the top view. Similarly, this point is B, the corresponding end is B1 is not seen in the top view. Similarly, C is seen, C1 is not seen, D is seen, D1 is not seen. The same way here I'll be mentioning A is seen but A1 is not seen. This point is B is seen, B is seen but B1 is not seen, C is seen but C1 is not seen, D is seen but D1 is not seen. Now I am going to be drawing the diagonals, which is nothing but the, so right now I have created a square prism. So here when I'm going to keep it in this view, the maximum number of faces which I can see is 3 faces, 2 lateral faces and 1 bottom face. To any extent I am going to tilt it, it will be a 3 faces. So now we are going to need to show what are visible edges. So I'm going to call this point as A, this is B, and this is C, and this one is D. This is actual solid, so we are going to keep it in the capital letters. The corresponding end of this A is here is A1, this is B, and this point is B1, this is C, C1, and this one is D1. Here we are going, what are the faces is seen is 2 lateral face, one is the top face, the other 2 faces, other 2 lateral faces. Here we are going to able to see the maximum number of faces is 3. So if I'm going to keep this solid like this, top face, 2 lateral faces, the other 2 lateral faces which is behind this and 1 bottom face is not visible. So what are seen, we are going to retain it in thick lines. What are not seen, we are going to make it as a hidden lines. So here A, B, B1, A1 is the lateral face. Similarly B, B1, C1, C is the lateral face. So we are going to retain it. A, B, C, D is nothing but the top face. D, D1, C1 is going to be is not seen, so we are going to make this one line as the hidden lines. Similarly A, A1, D1, D, D1, D1, A1 is not seen, we are going to keep this one as the hidden lines. So similarly I am going to consider an axis line, here an imaginary line I am going to be drawing from this point to this point. So it is a construction line. Similarly I am going to construct the same thing at the bottom also. Now I am going to be considering an axis line which is going to be the center of this square prism. So this axis line should be thin line and dash type line. So which is going to be, line should be like this. It is an axis line. A long dash, space, small dash, again space and long dash. This line should be thin lines. Now here we are going to be seeing the top view. Top view is A is seen, B is seen. Here if I'm going to see from the top, A, B, C, D is seen, A1, B1, C1, D1 is not seen. Now we are going to be finding the axis when this is nothing but the top face. A, B, C, D is seen. So that means I'm going to call this point as O point. For axis, I'm going to call this point as O. This is O1, which is not seen because it is at the base. So this is O1 is not visible. Similarly, the line joining D1 is not seen. So when the line joining is not seen, we are going to keep the annotations inside the bracket. Now we are going to be drawing its front view. Front view is going to be look like this is the front view. Now I have going to be seen it as the rectangular face, that is nothing but the lateral face. Here I am going to construct this. So I'm go for projection line, and the lines should be thin lines. Start it, end it here. See this point till here. So here I'll be able to see the O point, small letter O. This is the actual object. We kept everything in capital letters. This is the projections of this. So this should be in thin line. So this one is O1 is not seen. So once this is drawn, we are going to be seeing this face. The height of the prism is 60. So I'll go for draw this line. From here the length should be 60. Draw it in thick lines. So I'm going to draw it till here, draw it till here, and draw it. Now in front view I'll be able to see as an axis an imaginary line. So I'll be drawing this as a thin line. The axis line will start from here, not from here. This is in the top view. You are going to see the axis line as a point view. So from here I'll be able to see a line view. And this is going to be in thin lines. We are going to draw it very lightly. Now give its dimensions. So this height of the square prism is 60. Now when I am going to be keeping it in this way, we will be, if I am going to see from here, in top view I have seen it from here. So A, B, C, D was seen, A1, B1, C1, D1 is not visible. In front view I will be seeing it from here. That means A is seen, B is seen, B1 is seen, A1 is seen. But initially we have seen the top view where we are able to see this A, B, C, D, but A1, B1, C1, D1 was not seen. Now I am going to see from the front view. That means A is seen, B is seen, B1 is seen, A1 is seen, but C1, C, D, D1 is not seen. So if I'm going to see the view, this is the A point, this is B point, C is not seen, D is not seen in front view. Similarly, the corresponding point is A1, B1, which is seen, but C1 is not seen, D1 is also not seen in front view. So here I'll be keeping the annotations on VP. So this is going to be A dash is seen, but D is not seen. So D dash is not going to be seen. When I would see here, A is seen, D is not seen. Here B dash is seen, but C dash is not seen. The corresponding edges over here is A1 dash is seen, but D1 dash is not seen. Similarly, B1 dash is seen, C1 dash is not seen. Only I'll be able to see only face is this rectangle face. This one is A, this is B, this is B1, this is A1 is seen. That is what we have mentioned it here. A1, B1 is seen, C1 is not seen, D1 is not seen. Similarly, the axis point, if I'm going to keep it, axis point is located exactly at the center, but in front view it is not seen. That end point is not seen. Similarly, the base, here we got the point O1, in front view we are not able to see it. The same way here, I'll keep the O dash inside the bracket. Here O1 dash inside the bracket. The next step is, we are going to be seeing that one of the base edges of the base which is inclined VP at 30 degrees. So if it is on HP, the second step we are going to see is the inclination with respect to HP. So here, draw the projection of the prism when the axis is inclined to HP at 45 degrees. So now the same solid, I am going to tilt the axis 45 degrees with respect to HP. If I need to tilt the axis 45 degrees with respect to HP, that means even the lateral edges will also be inclined at 45 degrees. So while drawing, what I do is, I am going to be drawing a 45 degrees line. The length from B to B1 is equals to 60. So I'll draw a line from B1, the length of the line is 60, angle is going to be 45 degrees. 45 degrees to HP. Now this base edge is going to be perpendicular to the lateral edge. So if I'm going to click this is going to be 90 degrees. I need to make this base 90 degrees. So from this point, I'll be drawing another 45 degrees angle, and the length of this line is from here to here, which is equals to 35. Angle is 45. So I'll just draw 45 degrees line, 45 degrees line. This length should be equal to this. So I'll go for compass, cut an arc. The radius should be 35. Then I'll trim this. Now I'll keep the protractor and measure 90 degrees line. So from here, I'll draw line of the degrees, which is going to be, length is 60, angle is this much. Then after getting this distance equal to 60, I'll draw a line from here which should be equals to 35. Next, I am going to take the distance from B dash to O dash, that is equals to 35 divided by 2, 17.5. So I'll go for arc by center point. I'll select a compass and the radius is 17.5. I'll draw a line. Similarly, move the compass here 17.5. I'll draw an arc. So next is, I will take the roller scale and draw parallel lines here, or else you can just draw a line, and this is nothing but what I'm drawing is the locus line. This is how you are going to draw it manually. After drawing this, you trim this excess lines. And this is just for your understanding purpose. For 45 degrees, you need not retain it. In the question, what was said is the axis is inclined 45 degrees to HP. I made the lateral at 45 degrees so that I'm going to make the axis 45 degrees. So here I need to give the dimension for this axis line. For whatever the questions he has given, he says that the square side 35, axis length is 60, that means all the lateral edges is going to be 60. Now the axis is inclined 45 degrees to HP, so this axis is being inclined 45 degrees to HP. When I'm going to tilt it, still I'll be able to see this is A, B, here A1, B1 is seen, here also A, B, A1, B1 is visible. The same way, whatever the visible edges, visible points, we are going to be seeing it here also in the second step. So I'll be just writing the same annotations what was being kept earlier. Annotations belongs to VP, keep it in VP itself, do not cross the XY line. Keep the annotations above the XY line. Now I need to find how it is seen in the top view. So in front view we are able to see only rectangle, only one face. In top face, for the second step, we are able to see two faces, that is one top face, one lateral surface is visible. Now this is the view which I should be getting it here in the 2D view. So first things what we need to do is I'm going to draw thin lines. I'm going to project horizontal projections. I'm going to draw thin lines. Next, I'm going to project annotations by annotations. This is very important in projections of the solids. If you're going to miss any of those things, you're not going to get proper solid. So I'll take this A dash. A dash is nothing but the top face. I'm going to see where A is. So I'll project till A. So you're going to draw exactly perpendicular line. Similarly, I'll draw perpendicular line from this point to this point. So I'll give its annotations. What this point is A, this point is B, this point is C, and this point is D. So top face is completed. Now I'm going to do the same thing for the bottom face. So this one is A1. A1 is still this point. Then this is B1. B1 is still here. Let's write the annotations first. So this one is A1. This one is B1. This one is C1. This one is D1. Now first thing what you're going to do while solving it is we are going to be any view you're going to be seeing it, always the outer boundary of the solid is visible. Outer body of the solid is always visible. Anything you're going to tilt it. So this is nothing but the outer boundary. Any angle, there will be no hidden lines. So this is the outer boundary. From here, this is the outer boundary edge, outer boundary, outer boundary. This is the outer boundary, and this is the outer boundary. Now here we are going to do the same thing. Outer boundary of the solid is visible. So I'm going to make this one thick lines. So from this point to this point, outer boundary of the solid is visible. So I'll join this and join this. Next thing is the important thing here. So how it is seen in its top view, we already seen that top view is nothing but where I'm going to see from the top. So this is the nearest point. This point is A, this point is B, this is C, and this is D. the nearest point for the observer in top view is this edge. So this edge, that is nothing but A dash D dash, is the nearest point for the observer. Observer will look from here. So I'm going to see from the top. The nearest point for the observer is A and D. So A and D is the visible edge. So I'm going to draw it in thick lines. Here, for an observer, the farthest point in the top view, the farthest point is going to be the base edge. This is the base edge, is the farthest point for the top view. This edge will not be seen in the top view. So here, top view, I'll be able to see only two faces. The bottom edge is not seen. So the farthest point for an observer is not going to be visible. So I'm going to make this edge in the dotted lines. This should be thick dash type line. So in top view, this is the base edge. This is the base edge. This is the base edge joining this edge. This is the lateral edge joining this. Is not seen in the top view. I'll be able to see only these two faces. This edge is visible, but this edge is not visible. This edge is seen. This is nothing but the top edge, but the bottom edge is not seen. So the farthest point, if there is an edge which is not visible, that means line joining C1 to D1 is not seen. Similarly, C1 to C is also not seen, which is going to be dash type. But when it comes to the visibility criteria, visible edges will dominate the hidden edges. So that's why hidden line is not seen in the top view. So we can able to see it like this, the whole two faces properly. So if I'm going to see it in the line view, still this is nothing but the bottom edges, lateral bottom edge, this is the bottom edge, bottom edge, bottom edge, which is not seen. So in top view, this is nothing but we are going to see it. This is going to be a hidden line because it is at the base edges. Now after getting it, I am going to draw the axis line from this point. I'm going to always axis line. I'm going to do projections at the last to avoid the confusion. Always I'm going to do the projection of axis line at the last to avoid the confusion. So this is O point, and I'm going to project it till here. This is the O1 point, project till here. So I'm going to remove it. I'm going to draw this line as the axis line. This should be chain type line, like how we have drawn it here. This is the axis line. So when it comes to the visibility, this is nothing but the top face. So this O point is seen. This O1, A1, B1, C1, D1 is at the bottom face. If any of the edges is not seen, that means even the base will also be not visible. So we are going to keep this O1 inside the bracket. So this is what we're going to see even in the 3D view. Only we are going to see these two lateral, one lateral face, one top face. Then we shall move to the next step, which is we shall move to the next step, which is where one of its base edges of the base which is inclined VP at 30 degrees. So it is resting it on base edge is nothing but B1, C1 is the resting edge. So this is A, this is B, this is A1, this is B1, and this one is C1. It is resting it on B1, C1 edge. that B1 C1 edge need to be inclined 30 degrees with respect to VP. Now B1 C1 is an edge which I need to draw, incline it 30 degrees with respect to VP. So I'm going to draw a line initially which should be inclined to VP at initially I'm going to draw a line which is going to be inclined 30 degrees with respect to VP. Now I need to measure this B1 to C1 which is equals to 35. So I need to keep this make sure that this view, solid view, will not cross the XY line. I need to adjust it somehow because the distance from here to here is more compared to this. So that means it will require the space up till here. So I just made it. So I'll go for arc by center point. So from here C1 to B1 which is equals to 35. So I'll cut an arc. Now if I'm going to see with respect to this edge is going to be perpendicular line. So similarly I need to draw a line perpendicular to this 30 degrees. Similarly, I am going to draw the line from this end also. So I am going to draw it a line. I'll take the measurement from the compass. I'll take the distance from C1 to D will be equal to B1 to A. So I'll take this distance. So for me it is coming somewhat 17.68. I'll go for arc by center. I'm going to draw an arc which is of the radius 17.68. Similarly from this point, so when you're going to take the compass, you're not going to take any 0.68, you just take the measurement of this cut and arc. Now I'll be taking the measurement from this B1 to B is how much, which is equal to, for me it is getting it as 42.43. You can just directly measure it from the compass. From here I'll cut a radius now. From keeping this distance from B1 to A1 is how much? 24.75. I got it. I'll go again arc by center point. So from here I'll cut a radius now. I'm going to draw a line. Similarly, I'll just join it from this point to this point, this point to this point. You can just rub all the construction lines. Don't retain any construction lines. So I'll rub all these excess lines. Now I'll just copy the same thing. Do not change the annotation. So A is here, B point is here, C point is here, D point is here. Again go to the A1, do not go for B1 like that. Let's go with annotation by annotations. Then you are going to be drawing these lines, make it thick lines. So this one is the hidden edge, is done. The next thing is I need to show the access point. Now I'll be taking the distance from, or we have taken for everything with respect to the B1, so I'll take the distance from B1 to O. So I'll just take this distance B1 to O, and this distance is 34.78. so I'll cut an arc from this point, 34.78. I'll cut an arc. Similarly, I'll take the compass, move here, 34.78. Now I'll take the distance from B1 to O1. So this distance is 21.43. I'll go for arc by center point. I'll move to this point, radius, I'll take it correspondingly. From this point, now I'll draw the axis line, which should be thin line. So this is the axis line. These compass marks and all, rub it till it. So this is just for you to show it. You need not retain any lines, just took it for the correction. So this point is O1, this one is O. So next thing is how it is seen in its, so here I can tilt it either this way or the other way. So in this case the top face is visible, but this case bottom face is visible. That means I have tilted the base here. The other case is, actually in my problem I have tilted this one here. I can tilt either this way 30 degrees or I can tilt the other way. Here I am going to tilt it this way. This one has been tilted here. So when I am going to tilt like this, both are correct, but we need to maintain this 30 degrees. So as per the diagram what I have drawn is for this case. So I'll just show it for this one. So this is the top view what we have drawn. ABCD is in blue color, so this is ABCD. So this one is a given light cream colors, that is nothing but A1, D1 and D is this face. Now we have tilted. How it is seen in its front view. So this is the view I need to be getting it. So this is the first step. Second step, we need to give more number of faces in the third step. So how we are going to do it? So this is a very important step. You need to be projecting the lines in effective manner only by annotations. If you're going to miss it, the projections what you have done is going to be missing. So do not project A1 to the A, then it will result in oblique solids. So I'll take the point A point and project it till here. I'll go to the point, project it till here. This is nothing but B, project it here. Now go for the annotation A, check for this. This is the A point. A, where is A? A dash is here. So I'm going to project this one till that end point. Then go to the point B. B dash is here. I'm going to project till here. Then go to the point C. C is here. C should be here. Then D point. D should be kept till here. Then I'm going to rub this excess points. So I can keep the annotations. So this point is A dash. This one is B dash. This one is C dash. This one is D dash. Next I'm going for the bottom face. So from this A1 I'm going to project this. Project where is A1 is here. Project this one till where A1 is there located. Then go to the point B1 and I'm going to keep it B1 is here. I'm going to project B1 here. Go to C1, which is again at the base. It is restricted on the edge, B1 C1 edge. So this is D1. I'm going to project it. So I'm going to trim this. I'm not going to return any excess lines to avoid the confusions. I'll give you annotations. So this point is A1 dash. This one is B1 dash. This is C1 dash. This is D1 dash. Next thing is what is important is why solving it here is we need to join the outer boundary of the solid in the thick lines. So here also I'm going to do the same way. So I'll go to the C1. This is B1. It is B1 to B and to the A point until here, then here D1 to D, then to C. So we are joined the outer boundary of the solid. Now I need to do the same way what I have done the other way while getting the top view. Now I'm going to see from here. The nearest point for an observer is A1. That means line joining A1 should be thick lines, like how it was getting the top view. The nearest point for observer is AD. AD was a thick line. Line joining AD should be thick line. The same way here, the nearest point is nothing but A1. Line joining A1 should be thick lines. So A1 is joining till where? So this is nothing but the A1. A1 to A, A1 to B1, A1 to D1 is the lines which are connecting to A1. Similarly here A1 is joining to A, A1 to B1 is a thick line, A1 to D1 is the visible edges. The next thing is, as an observer, here the farthest point for an observer was B1 C1, so it was in dotted lines. Similarly, the farthest point for an observer is C. Nearest point is A1, farthest is C, so line joining C must be in dotted. So that means from C it is joining to D, C is joining to B, and C need to be joined to C1. So it is joined. If I need to see, here all edges are 60 axis lateral. Even if you tilt it, it is going to be 60. Here also, when I'm going to tilt it, all the edges is going to be in the apparent length. So this is whatever this length is 47. Similar, this one is also 47. This one is also 47. This one is also be 47. If this is 35, this is also an apparent length because it is having inclination with respect to HP as also with respect to VP. So this is also an apparent length. This comes around 30. Here this one also should be 30. This is also should be 30. This also should be 30. This is something around 27.5. This one should be parallel to this and also should be equal. This should be equal. This should be equal. After drawing all these things, we are going to project the axis line at the last. So I'm going to project this one till here. After projection all, I'm going to project the axis line at the last. From here. So this is O1 where it intersects, so make sure that this point. Similarly, it need to be joined from here to here. It is axis line. If any face contains a hidden line, that means that face is not visible. So here in this case, C line joining C is dotted, so C dash should be hidden. That means the top face ABCD is not seen. That means the annotations, that is nothing but the axis line for this O dash is not visible. Here O1 dash is visible for the bottom face. Now the bottom face is visible, so this should be outside the bracket. So bottom face is seen, top face is not seen. So here this face is nothing but this face. This is nothing but the top face which has been inclined. This is nothing but the top face. So if I'm going to see the top view, I'll be able to see these two faces. That is what we are going to be seeing it here. In front view, this is the front view. So that means three faces is visible. Here also three faces is going to be in thick lines. A1, B1, B, A is thick line. A1, D1, D is thick line. D1, C1, B1, A1 is comes under the bottom face which is visible. So these dimensions you need not retain it. This is just for your reference. Whatever the solid has given, we need to maintain. This 90 degrees is for your reference. This 70.5 is for your reference. This is a square. So make sure that you are going to add prefix. I hope you understood the concept of projection of solids, and also understood about the hidden lines, and also understood how about you're going to keep the concepts. Have a good day.